Hello, good morning students. Welcome to my channel, and today I am going to discuss about rest of the applications of normal curve from application number 7. So according to the application number 7, normal curve is used to determine the percentile points or the limits in terms of scores which include the lowest given percentages of cases. Okay, it means that normal curve is used to determine the percentile points or upper limit. The limits in terms of scores, it means the upper limit or lower limit of scores which cuts the lowest given percentage of cases. There is one problem given here, and I will go according to this problem. Given a normal distribution n is equal to 1000, m 80, and sigma 16. Determine the percentile p30. Okay, so here you need to understand first the problem. Here, what you need to find out. What do you understand by determining percentile p30? In determining percentile p30, we need to understand that we have to look for a score point below which 30% of the cases lie. Okay, it means that whenever you are supposed to find out the percentile point, that you need to understand that you need to find out one score point below which certain percentage of cases lie. So here, in order to find out P30 means we need to find out a score point below which 30% of the cases lie. Okay, so everything is written here clearly, and we need to first understand the thing, because here you see, here when we come to know about this point, that we need to find out now the score point below which 30% of the cases lie. Now we need to find out the sigma value for 20% of the cases which may lie on the left side of the mean. And as you all know that 50% lies on both the sides of the mean. So 50 minus 30 is equal to 20% of the cases lie on the left side of the mean. Okay, so now we need to find out the sigma distance from normal curve table for 20% or 2000. 20% means 2000 out of 10,000 cases. It is not 1,000, it is 10,000 cases. So here we need to interpolate. Why we need to interpolate? We need to interpolate in order to find out the exact sigma distance. And by interpolation, as I have shown you the interpolation method in my previous sum, so you may understand about this interpolation. So by interpolation, we need to find out now the sigma value for 20% or 2000 cases out of 10,000. So what we get here, the sigma value as 0.525 sigma by looking at the normal curve table. Okay, now what we need to do here is that we need to put the values in the formula that which we know the formula. Okay, by putting the values in the formula, what we will get here, the score as 71.6 or 72. Okay, so does the required score will be found? You all may come to know about this point, that we put the values in the formula and what we found the score here as 71.6 or 72. Thus what we get here is that the score is 71 or 72, which we can, make it as round figure, which is 72. Okay. Okay, now you please try to follow this graph as presented in the graph, that according to the sum, we were supposed to find out the score point below which 30% of the cases lie. Below which 30% of the cases lie. So here we found out the sigma value as 0.525 sigma on the left side of the mean. Okay, for sigma value for 20% of the cases, which we found out by, subtracting 30 from 50%. As we all know, 50% lies on both the sides of the mean. So 50 minus 30 is equal to 20, and we found out the sigma value for 20% of the cases, which we got as 0.525 sigma by interpolating the values. Okay, now we found out the score as 72 by putting the values in the same formula. Okay, so now what we can tell here, that, or how we can tell here, that the limits in terms of scores, which include the lowest 30% of the cases. Now we can conclude like that the upper limit of these cases may now be given by the score point 71.6 or 72, and the lower limit will be the lowest score of the distribution. So 71.6 or 72 is the upper limit of the cases, okay, which may include the lowest 30% of the cases. So the upper limit of the lowest 30% of the cases is 72, and the lower limit will be the lowest score of the distribution. As you all know that when we go to this part, then we will get the lower or lowest score, and when we will go to this side, then we will get the upper score. Okay, as it is the positive side and it is the negative side. Okay, I hope you are clear about my point. Now I am going to talk about the application number 8. Okay, so according to the application number 8, normal curve is used to determine the relative difficulty value of the test items. From this concept, we can understand that normal curve can be used to find out the difficulty value of test items, okay, given in a scale, and the relative difficulty values of the items given in a particular scale or inventory. Okay, so it is the point to understand here, and I'll go through this problem. According to this problem, 4 problems A, B, C, and D have been solved by 50%, 60%, 70%, and 80% respectively of a large group. Now compare the difference in difficulty between A and B with the difference between C and D. Now we need to go for the solution here. Okay. So according to the normal curve, you try to understand here that problem A is solved by 50% of the group. Okay. Problem B is solved by 60%. It means 10% more students or individuals are added to the group to solve the problem B. Then again, problem C is solved by 70%. Then 10% or 20% were more added to 50%. Okay. Then again, problem D is solved by 80% of a particular group which were added. Okay, added means on this side we will have the positive more numbers of this highest numbers of this students. Okay, so it is the concept pertaining to normal curve. Now it is very simple to understand because you see here that now we need to find out the difficulty value as well as relative difficulty value for problem A and B and C and D. Okay, so now our first work is to find out the difficulty value for each of the problems. Okay, so please look here. Okay, for problem A, we see that it has been solved by 50% of the group. It means that the remaining 50% of the group are unable to solve the problem. So the difficulty value of the problem will be 0 because 50 minus 50 is equal to 0. As we all know that 50% lies on both the sides of the mean in case of normal curve. Okay, so the difficulty value for problem A is 0. Okay, now in case of problem B, okay, as we see that problem B is solved by 60% of the group. Okay, it means that in comparison to problem A, 10% more individuals in the group are able to solve it. Now we need to find out the sigma distance for 10% or 1,000 individuals out of 10,000 individuals. And by interpolating the values, we will get the sigma value as 0.253. And as it will be on the left side of the mean, as you have noticed in the graph, so the difficulty value for problem B will be minus 0.253 sigma. Okay, so similarly, we can determine the difficulty value for problem C and problem D. Okay, problem C is solved by 70% of the group. It means 20% more individuals of the group are able to solve problem C. So here we need to find out the sigma distance for 20% or 2,000 out of 10,000 of the cases. And by interpolating the exact location, we find the sigma value as 0.525. Okay, as it will be on the left side of the mean, so the difficulty value for problem C is minus 0.525 sigma. And likewise, the difficulty value for problem D will be minus 0.840 sigma. Because problem D is solved by 80% of the group. It means 30% more individuals than the average are able to solve this problem. So now we need to find out the sigma value for 30% or 3000 out of 10,000 of the cases from normal curve table. And by interpolating the exact value, what we will get here as minus 0.840 sigma. So the difficulty value for problem D is minus 0.840 sigma. Now, according to the problem, we need to find out the relative difficulty value. So you can write like this table too. Problem A is solved by 50%. Difficulty value will be 0. Problem B is solved by 60%. Difficulty value will be minus 0.253 sigma. Then you need to find out the relative difficulty value, means sigma differences. And the relative difficulty value for problem A and B is minus 0.253 sigma. Okay, again, problem C is solved by 70%. And the difficulty value is minus 0.525 sigma. Again, problem D is solved by 80% and the difficulty value is minus 0.840 sigma. And now we need to find out the relative difficulty value according to our problem, which is that minus 0.315 for problem C and D. Okay, now how we can interpret here is that we can conclude that problem B is simpler than problem A by having 0.253 sigma, less difficulty value as it is minus, so less difficulty value, and similarly problem D is simpler than problem C by having 0.315 sigma, less difficulty value. Why less difficulty value? Because it is on the left side and it is the minus sign. Okay, so it is the thing. I hope you are getting this problem clear. Okay, now we have another example of this same type. 3 questions. Sorry, okay. Please wait. Having any confusion, please, tell me. You can comment me. Okay, so this is the problem of the same type of application. 3 questions are solved by 20%, 30%, and 40% respectively of a large unrelated group. Now, if we assume the ability measured by the test questions to be distributed normally, find out the relative difficulty value of these questions. So again, we need to find out the relative difficulty value of these questions. So first, when we are supposed to go through the normal curve, then we just try to understand here is that problem A is solved by 20%. So 20% will be less, which will be lie here. Problem B is solved by 30%. Okay, 30% more, 10% are more added to the group. Okay, from 20%. Then again, problem C is solved by 40%. of the group within 50% of cases. Okay, so it is the graphical representation of this problem. So now first we need to find out the difficulty value, then we can find out the relative difficulty value. So it is very simple to understand because questions A, B and C are solved by 20%, 30% and 40% of the group. Therefore, from the point of view of difficulty, question A is the most difficult one in comparison to question B and C, because A is solved by only 20% out of 50%. When we see that problem B is solved by 30% and problem C is solved by 40%. So we can clearly understand here that problem A is difficult from problem B and C. Okay, now we need to find out the difficulty value as well as the relative difficulty value. Okay, now question A has been solved by only 20% of the group. So we need to now find out the sigma value for 30% of the cases, 30% or 3000 out of 10,000. Because as you all know that 50 minus 20 is equal to 30%. Okay, and the sigma value is 0.844 sigma. Okay, so here what we will do is that we need to find out first the difficulty value for each of the question. So here we find the difficulty value for question A is 0.844 sigma. So similarly, we need to find out the difficulty value for question B, which is solved by 30% of the group. It means that it can be, told like that. Problem B solved by 30% of the group, which can be determined by locating a point on the baseline above and below which 30% and 70% cases lie. Okay, if we see from the perspective of 100%, then out of 100%, only 30% of the group, 30% of the individuals are able to solve problem B. So it means 70% are unable to solve the problem if we assume from the perspective of 100%. Okay, now according to the problem B is solved by 30%. So now we need to find out the sigma value for 20% of the cases. 20% or 2000 out of 10,000 cases. And the sigma value is 0.525 sigma. And as you noticed in the normal graph, the representation of this problem, the representation of the sigma value in the normal curve. Okay, I hope you may understand about these points in the normal graph. Okay, so here the difficulty value of question B is 0.525 sigma. Okay, I hope you are clear. Now question C is solved by 40%. Okay, it means we need to find out the sigma value for 10% or 1000 out of 10,000 cases. Okay, and we get the sigma value for 10% or 1000 is 0.253 sigma. So here the difficulty value of question C is 0.253 sigma. Okay, I hope you are getting my point clear. Having doubt, you please comment me. Okay. Okay, please wait. Now we can summarize the results as given in the table. We can do like this table too. Okay. Okay. Now, according to the problem, question A is solved by 20% and the difficulty value is 0.844 sigma. Problem B is solved by 30% and the difficulty value is 0.525 sigma, and question C is solved by 40% of the group and the difficulty value is 0.253 sigma. And we can find out the relative difficulty value too if we are asked for this thing. Okay, so it is the application number 8. I hope you may have understood this application. Now I am going to talk about application number 9. Okay, according to this application, normal curve is used to divide a given group into categories according to an ability or trait assumed to be distributed normally. So we can understand here is that normal curve can be used to divide a given group into different categories depending on their different abilities or personality traits. Okay, so let us begin with a problem. There is a group of 200 students that has to be classified into 5 categories A, B, C, D, and E according to ability, the range of ability being equal in each category. If the trait counted under ability is normally distributed, tell how many students should be placed in each category A, B, C, D, and E. We need to now find out the percentage of students or the number of students, okay, lying in category A, category B, category C, category D, and E. Okay, so it is the problem. Now it is very simple to understand because you see in this curve, okay, each of the categories are shown here in normal curve. The first important concept you need to know here is that, as you all know, that the normal curve extends from +3 sigma to -3 sigma. Okay, so we can assume that we have ±6 sigma lying in this, area. Okay, according to this concept. Okay, and now according to our problem, we need to, make 5 categories and we need to find out the percentage of cases or number of students lying in each of the category. So 5 category. Now what we need to do here is that 6 divided by 5, and if we calculate this 6 divided by 5, then we will get 1.2 sigma. So here you need to subtract 1.2 sigma from this +3 sigma. And if you calculate this by subtracting 1.2 sigma from +3 sigma, you will get 1.8 sigma. Then again, if you subtract 1.2 sigma from 1.8 sigma, then you will get +6.6 sigma. Then if you subtract 1.2 sigma from +6 sigma, then you will get -0.6 sigma. Then you will similarly get this types of values. But after that, what you need to do here is that you need to find out the percentage of cases or number of individuals lying in each of the categories. So it is your main work. Okay, I hope you are getting this point clear. Okay, so after representing the particular areas in the curve, we need to find out the percentage of cases or number of individuals lying in each of the categories. So please see carefully. Okay, so let us begin the task with area A. As you noticed that it extends from 1.8 sigma to 3 sigma. To know the percentage of cases falling within this area, we read from the table the cases lying between mean and 3 sigma. And from the normal curve table, we got the percentage of cases for 3 sigma as 49.86%. And again, we need to find out the percentage of cases for 1.8 sigma, and which we get as 46.41% cases for 1.8 sigma. Now, in order to find out the number of individuals or percentage of cases lying between plus 3 sigma to plus 1.8 sigma, what we need to do is that we need to subtract 46.41% from 49.86%, and we get 3.45% lying in area A. So we can conclude here that group A may be said to comprise of 3.45% or 3.5% of the whole group. You try to relate this percentage, this calculation with the graphical representation. Okay, I hope you may come to understand this point. Okay, similarly, group B covers the cases lying between 0.6 sigma and 1.8 sigma. So here again, we need to find out the percentage of cases for 6 sigma and as well as 1.8 sigma, which we already know as 46.41%. Now, the percentage of cases for 6 sigma is 22.57%. So in order to find out the percentage of cases lying in area B, we need to subtract 22.57% from 46.41%, and we get 23.84% as the area comprising B. Okay, so similarly, we need to find out the area for group C, D, and E. As you can notice in the graph that group C extends from minus 0.6 sigma to 0.6 sigma plus 0.6 sigma on both sides of the mean. So as we already know about the percentage of cases for 6 sigma. So now we need to find out the area of cases lying on group C. Okay, so what we need to do here is that we need to multiply 22.57 into 2, and we get 45.14 or 45% comprising area or group C. Okay, so similarly, we can find out the areas for group D and E. Okay, as I showed you in the figure, okay, which is identical to group B and A. So therefore we can find that, we can find therefore, identical to B and A, and therefore may be found to consist of the same percentage of cases as covered in groups B and A respectively. For example, 23.8% and 0.5% of the whole group. So it is very simple to understand. You just relate with the graphical representation of the problem. So we can summarize the finding in this table. First of all, we need to write that the percentage of the whole group in each category, which is 3.5% for A, 23.8% for B, 45% for C, 23.8 for D, and 3.5 for E. Now, number of students in each category out of the total 200 students. So we need to find out the, total students. We need to convert this into, round figure. We can convert. We can, find out of 200 students according to the given problem. Now, by doing calculation, what we get here is that number of students in each category out of total 200. 3.5 divided by 100 into 200. So you will get 7.0. Here 23.8 divided by 100 into 200. You will get 47.6. Similarly, 90 for C, 47.6 for D, which is similar. D and E, the cases for D and E will be similar to A and B. Okay, I hope you are getting this point clear. Now we can convert this into round figure, whole number, as 7, 7.7 for 7.0, 48 for 47.6, 90 for 90.0, 48 for 47.6, 7 for 7.0. So it is all the application number 8. Okay, I just try to let you show some, little thing in the graph. Okay, please wait. I'm bringing you to the graph. It is in the previous page. Okay, so you can find here that according to this graph, we are very clear about this portion. Okay, now after this, we need to find out the percentage of cases for 3 sigma, percentage of cases for 1.8 sigma. Now we need to find out this portion A. So what we need to do here is that we need to subtract 1.8. 1.8, what the percentage of cases we may get for 1.8 will be subtracted from this whole part, from 3 sigma. For 3 sigma, what the percentage of cases we may supposed to get, we need to subtract. We need to subtract this percentage of cases from this. Then we will get this portion. Similarly, we need to subtract this portion, percentage of cases for 0.6 sigma or 6 sigma from 1.8 sigma, the percentage of cases. So we can get the percentage of cases or number of students or number of individuals lying in group B. Similarly, when we try to find out the percentage of cases lying in this area, so here, we need to add the, both the sides, add, which was 22.57. Okay, 22.57 into 2 or 22.57 plus 22.57, we can get the total number of cases lying in group C. So similarly, we can find the area in group D and or number of cases or number of students or individuals, whatever it is, in area D as well as in area E, which will be same like A and B, but you need to do this thing. You need to calculate the portion. Okay, so it is all about this application. I hope you may have understood this application, and having any confusion, you can ask me, you can make comment, okay, so that I can, try my best to give you the best, okay. So with this hope, today I am ending my video. Thank you so much. Thank you for listening. Thank you for keep patience to listen me, okay, and do study and take care. Okay, bye.